next one asks us to factor this polynomial f of x and then sketch its graph. So we're not provided the function in factored form, so we have to factor it first. And this is going to pull us back to factor by grouping, right? So that's the direction we're moving. Eventually, we're going to give you a polynomial in standard form and ask you to find all of its roots or zeros, graph it, factor it. So we have to factor this polynomial. So we're going to start with the polynomial x cubed minus 2x squared minus 4x plus 8, okay? And this is going to be one technique. This technique only works when it actually factors by grouping. There are other cases. So we're going to group the first two terms of this polynomial and then the second two terms. And I personally don't like the subtraction in between the middle two terms here. So what I'm going to do is I'm going to change this to addition and make the negative, make it a negative 4x there. So then we're going to group the first two terms, right? This is factor by grouping. So in the first group, I can factor out an x squared. So x squared comes out, and what's left with the remaining factor here is x minus 2. Now, when I factor my second group here, I want my, whatever I factor out, I want my next factor, or the corresponding factor, to be x minus 2 again. So for that to occur, I need to factor out a negative 4. And that's going to leave me with x minus 2 now. Last step of factor by grouping, there's still two terms on the board. Both terms contain an x minus 2 as a factor. So I'm going to now factor x minus 2 out of the two terms there. What I'm left with is x squared minus 4. And then remember, this is all equal to f of x. Just writing f of x on the right side of the equation now. Completely factored is the way we want to go. So this red factor here will actually factor, because it's a difference of two squares, into x plus 2 times quantity x minus 2. And then there's that blue factor right here, x minus 2. And then again, equal to f of x. So as I'm looking at this, I'm noticing I have an x minus 2 factor in green and a blue x minus 2 factor here. So I'm going to restructure this because that's multiplicity, and we should note that before we start graphing. So we have an x minus 2 factor with multiplicity 2 right there, and then an x plus 2 factor here as well. From this, I'm going to pull zeros. Okay, so my first zero from the x minus 2 squared is going to indicate that I have a 0 at positive 2, and this is with multiplicity 2. And then I have another factor, or 0, at x equals negative 2. Right? And from here, we can start graphing it just like we did. Looking at the original function, right? I know it's a degree 3. From here, I know my leading coefficient is 1. Therefore, my graph should look something like this, but also keep in mind that there's multiplicity. So it's going to touch that root at 2 and just turn away. But the important thing here is that over time, as the x values move to the right increase, the y values are going to be increasing towards infinity, right? So zeros would be negative 2. What I'm going to do is I'm going to just change my scale here. So negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4, and then same, 1, 2, 3, 4. I'm hoping this is going to work on my y-axis with this scale. If not, I'll modify it. So I have a 0 at positive 2 right here. There's multiplicity 2 at that point, and then I also have a 0 at negative 2. Whoops, I already messed this up. This point should actually be here. And then I have another 0 at negative 2 right there. What else can I determine from this? This is a constant, which also means my y-intercept is 0, 8, and I've kind of already messed my y-axis scale up. So I'm going to quick change that, right? I'm going to change it back to scale of 1. So this is really 8, and this is 4, and then this is negative 4 and negative 8. So my x-axis scale is the only one that's really modified. So I have a y-intercept at 0, 8. That's helpful. I have a double root multiplicity 2 at x equals 2. So it's going to just touch that and turn away. So in this case, we can kind of get away with just sketching it as is because of the multiplicity, right? So graph's going to come up through my first 0 here. It's going to come back through here, and it's going to start coming down to this 0, and as soon as it touches it, it's going to turn back away and start heading up again. And this, again, remember, it's a sketch. So we got lucky here because between the two zeros, the two red zeros right here, here and here, I do have a y-intercept up there at 8. So that's nice. And then again, because of the multiplicity here at this point, it's going to bend back around and start going up again. So this is a fairly accurate sketch of the graph we're trying to make.